Good morning and welcome to part 3 of Online Math Thinking Fundamentals, the series where we learn how to learn like a mathematician. Today's topic is inverse. Oh, wait. Oh, hang on. Sorry. It's upside down. Let me fix this. There we go. Right? Doing the opposite. Doing things backwards and or upside down, right? That's what we're talking about today. And to illustrate the idea of inverse, I'm going to start with a number we all know and love, 1/2, right? Half is one of my favorite numbers because it is probably the best example of sharing I know. How much of the pie can I eat? Well, you can have half and your brother gets the other half. How much of the pizza can I have? You can have half and your brother gets the other half. Maybe it's just because I have exactly one brother. Those of you with 2 siblings, you are probably more familiar with 1/3, okay? But I'm going to start with a half, right? And this is a number, so we're back to that idea. Let's think about numbers and their properties. It's a special number because it is an inverse. In fact, it's the, let's get fancy here, I'm running out of space. Multiplicative inverse of 2. Right? The opposite of multiplying by 2, of doubling something, is multiplying by 1/2. And you can see that's what it looks like. The way we write 1/2 is it looks like I'm taking something right here and dividing it by 2, right? Because division is the inverse operation of multiplication, right? Actually, I'll branch that off of here, right? Multiplication versus division. And we can also think about additive inverses, right? We also have plus versus minus. That's another type of inverse. It is the opposite operation. It's going backwards. We started with numbers. We started with a system of counting. How can I figure out how many more things I have? And then at some point we registered, hey, wait a minute, sometimes I don't gain things, I lose them. Right? This is the bad news, right? Day 1, cavemen count sticks. Day 2, caveman loses a stick. Where to go, right? Suddenly we have to work backwards. And so now we've got to think of not just how can I make something happen, how can I undo that thing? The power of Control Z. How do you read it? CTRL plus Z, right? Probably one of the favorite keyboard shortcuts worldwide. Control Z, undo. This is a very powerful tool because we just talked about how everything in math is a type of relationship. Well, as it turns out, a lot of those relationships are also processes, operations, as I've demonstrated, right, with the add and subtract and the multiply and divide here. And so being able to undo those operations unlocks a lot of possibilities. Something else I'd like to illustrate here in the realm of inverse. We have one of the common applications of math is towards doing science. And I think inverse illustrates one of the key differences. It is best exemplified through a quotation. When a scientist discovers something new, they will often think to themselves, that was interesting. How can I make that happen again? Right? It's not science until it's repeatable, until you can do it again and again on a consistent basis and make a prediction of what will happen after that. That's the scientific method. Predictability, repeatability. How can I do this again? Mathematics, though, is looking more for a system. And inside the system of operations, there is always, or at least the theory is, there is always a way to undo, a way to reverse. And so when a mathematician comes across something new and interesting, they think, aha, that was great. How can I undo it? Which sounds kind of counterproductive. It's like, oh, I just made this great thing. Okay, how can I tear it back down again? Because they want to understand what the system is. What are its rules and regulations? How can I move forward, backward? All right, and all of the functions do this. Every operation, right? Multiplication turns into division. Right? You have your y equals 2x plus 5, right? You've seen that in school, and you've seen, okay, what is the inverse operation? What is the reverse? Going backwards. Instead of multiplying by 2, then adding 5, I need to first subtract the 5 and then divide by 2. So it's the opposite operations in the opposite order. We've got opposite compounding on opposite, right? All of these can be undone. And speaking of opposite, what do we do with, actually, let's switch colors here, right? We're going crazy now. What about this opposite, right? This is also a type of inverse, negatives, right? That connects to the, if I can get them all on screen here, the plus versus minus, right? It's the additive inverse, adding and subtracting. We had positive numbers, then we had negative numbers, right? When we're dealing in the realm of multiplication, the opposite is division, so it's inverse operation. Division gives us the halves, the fractions that are written as division. The negative numbers, by no accident, are written out as subtract this. From what? Doesn't matter, right? Just add that on to the end, right? Minus 2. We can have the opposites and the inverses. We could even go, really crazy and say negative 1/2. Oh my gosh. Opposite and an inverse, right? And these words can be used interchangeably to some extent, right? Specifically, opposite often in math refers to the negative, and the inverse often refers to the half or the divide by, or further more complex operations. But I want you to start thinking about everything in terms of itself and its inverse, right? Every coin has two sides to it. Every math operation has two sides to it. So reflect on how can I find its inverse. And you'll gain quite a few benefits. One, saving just mental space, right? Do not think about the 4 basic operations. There are only 2. There is addition and there is multiplication, right? Addition has its opposite of subtraction. That's just adding a negative, right? It's really just addition, but backwards. Multiplication has its opposite, division. There is no such thing as dividing. It's just reverse multiplying, okay? Same way that a scientist, physicist would say, there is no such thing as deceleration. It's just acceleration in the negative direction, okay? Yes, it's a convenient word for talking about a specific category, but really it doesn't exist separate from the other. Okay? We can get all philosophical and talk about the existence or non-existence of darkness, and in reality it's just absence of light, right? That kind of thing. Everything has its opposite. And so that state of mind will, one, save you from a list of things, right? It'll just cut everything in half, what you have to deal with. But it's also a very powerful tool, as highlighted right here. This is a very basic Algebra 1 type example, but this is using the inverse process to a new end. It is solving for something else. It is working backwards, right? That's powerful enough. I'm going to write that down, okay? Working backwards. And that just connects up to everything. Everything here is working backwards, right? That is one of the most powerful tools you have in your toolbox of figuring out and working through a problem to say, okay, what if I started at the end? How could I arrive there and work backwards? And then when you find out, oh, the last thing I would have had to do is divide by 2. So I know the inverse, at some point in my forwards thinking process, I'm going to have to multiply by 2. And so that is where this idea of inverse really starts to shine. And it's going to be an idea you're going to need throughout mathematics, okay? The plan for this series is to build up concept by concept, and we're going to cover things that are used from Algebra 1 through top-end calculus, differential equations, all that good stuff is founded upon quantity, relationships, inverse, and more in the rest of the series. Okay. I think that's about all I have for today. If you want to get just a little bit more out of this video, go online, find a strange website that will let you play it backwards, okay, and see what that sounds like. That would be actually really fun to do. I might try that myself. But otherwise, this is the end. Thank you so much for watching. So long, farewell, enjoy the rest of your day.